Hello everyone, welcome to another video. This is the first video in Docker for DevOps learning series. So this video is for absolute beginners. If you don't know from where to start your container journey in DevOps, this is the perfect video to get started with it. Okay, so on my screen, you can see the contents that I'll be covering in this video. So we'll start with what is Docker and why we need it. Then we will see how we can install and configure Docker on our machine. Then I'll be showing you how to run your first Docker container. Then we'll be running a meaningful application like Jenkins as a Docker container, and we'll see how we can access Jenkins inside a Docker container. Then I'll be talking about some of the most commonly used Docker commands. Then I'll talk about the difference between a Docker image and a Docker container. And at the last, we will see Docker's architecture. All right. So what is Docker? Docker is just a piece of software or a tool or a platform which is used to deploy an application as a container. We have multiple ways by which we can deploy an application. So Docker is just one of the ways. But when we use Docker, it deploys your application as a container. I'll be talking about the concepts around container and its definition as well. Okay, but just understand that it is just a tool to deploy an application as a container. Now, the next important thing to understand for anyone is why the entire DevOps world is crazy about Docker containers. Why they want to deploy their application as container. Because when Docker wasn't there, even then the applications were being deployed. So how Docker is being so beneficial to us that we all want to learn it and deploy our applications as container. To make you understand that, I have taken an example of one of the applications that I deployed in one of my past videos. So as you can see on the screen, this was the project, and let me explain you this. What I was trying to do, I took one AWS EC2 instance running Amazon Linux AMI, and on top of it, I was trying to install 3 different packages: PHP, HTTPD, and Drupal as part of the main application stack to host a WordPress website. Okay. Now, in this scenario, what usually can happen, the first thing is you have to identify one operating system which is compatible with all the 3 different packages that you want to install as part of your application stack. Okay, so you have to identify the right operating system. Then other issue that could arise is each application package can have their own dependent library which should be there on the operating system installed in advance for the installation of this package to work. For example, if I talk about PHP, so I'm just taking a random example here. Suppose PHP package needs library version 1 to be installed in advance on this operating system, on this EC2 instance. So you have to ensure that library v1 is already installed. Similarly for HTTPD, suppose the library version is required, it is the v2 version that it needs. So you have to again ensure that this library v2 is already installed, else the installation may fail. Okay. And then similarly for Drupal, it is library v3, for example. Okay, so in this case, you have to face a lot of challenges depending on what operating system you are using. You have to ensure that that same operating system is compatible with all the 3 these different application packages that you want to install. Then if they have some dependency on some library, so all those libraries have to be installed in advance on the operating system itself, else the installation is going to fail. Now suppose somehow you are able to negotiate that and you are able to install the different versions of the same library to support the different application packages as part of your application stack. Okay, so it works well when the scenario is pretty simple. Okay, but when the scenario gets really complicated, so then we have a lot of challenges in this type of application deployment setup. How? Let's see that in the next slide. Now, suppose there's a requirement to have an additional functionality in your application. For that, you have to update this PHP v1 to PHP v2. Okay, And one more scenario could be there is a critical security vulnerability that is reported in this Drupal v1 version, and security team is chasing you to update this Drupal v1 version to Drupal v2 to remediate that. Okay, and this is a very real-time scenario. We have to keep updating these versions from time to time, okay, depending on one scenario or the other. Now, when you are updating this PHP v1 to PHP v2, the dependent library version may also change. Okay, in this example, as you can see, PHP v1 required library version 1, but PHP v2 it needs library version 2. Okay, similarly for Drupal with v1 version it only needed this library v3, but with this v2 version of Drupal it needs library v4. Also, if you see, we also have installed this MySQL v1 version and Python v1 version. Okay, I'm just taking a random example. I know, I mean, Python has a different version notation, but I'm just taking a very random example to make you explain the concept. So for example, you also have another application hosted on this EC2 instance because you have some unused resources on this instance and you want to utilize it for other application. So you have installed this MySQL v1 and this Python v1 package on the same EC2 instance, and they have their own dependency. Like this MySQL v1 is dependent on library v3, v4 and v5. Similarly, this Python v1 is dependent on library v3, v4, v5 and v6. Now, as I mentioned, this PHP v1 is to be updated to PHP v2, and this Drupal v1 is to be updated to Drupal v2. Okay, and this PHP v2 now needs library v2, okay, to be there on the operating system. Similarly, for this Drupal v2 version, it needs library v4. Okay, and one more requirement is there, that you have to update this Python v1 from v1 to v2 version. So again, the dependent libraries have changed, and it is now lib v5, v6, v7 and v8. So if you see here, this scenario is getting really complex, and manually you have to ensure that all the dependent libraries of the different packages and their versions are installed on the same operating system. Okay, so this is not what we want. Okay, and this is where we can take help from a containerization platform like Docker. Let's see it in the next slide. So here, as you can see, instead of installing these three packages directly on our EC2 instance, what we are trying to do here is we are trying to create an object which is called Docker image. This image is a single file that is going to comprise of our main application package plus all of its dependencies and libraries together. Okay, so here as you can see, we have created three different Docker images, one for Drupal, one for HTTPD and one for PHP. And then this image one is going to be used to create this container one on our EC2 instance. Okay, because we have installed Docker software on our EC2 instance, and this is going to give us the capability to run Docker run commands. Okay, which is used to create the containers. Okay, but this Docker run command, it needs a Docker image. Okay, so we are going to create these images for each of these application packages together. Okay, and then these images are going to be run as container on our EC2 instance after we install this Docker tool on our EC2 instance. Now, the main advantage of doing this is, in case we have to update this particular package, for example, this is PHP v1. Okay, now we have to install PHP v2, and then we have to update its dependencies also from this library v1 to library v2. In that case, we can do so inside this container only, because each container that you run, okay, on this EC2 instance is going to be completely isolated from the other two containers, which means that this particular container is like a small virtual machine on this EC2 instance, and it has its own storage and networking. Okay, and so whatever you do inside the container remains inside the container by default. Okay, similarly for this HTTPD package, you can do the same, and for other containers also which are there on your EC2 instance. So in this way, any installation that we do for a particular application package, it is not going to do any interference with the other two installations. Okay, just because these three containers are completely isolated from each other by default. Okay, so so step one is to create a Docker image for each of your this package. It's going to have the main application package and all of its dependencies and libraries that this package needs to run, and then you can use Docker run commands to create the containers from these Docker images. Okay, then one more thing we can do with these Docker images. Suppose someone else wants to run these containers on his machine, and he's sitting somewhere. I mean, he's sitting in some other country, okay, around the world. So in that case, you can push these images to a repository and then share that repository with that user who wants to run these containers. All he needs to ensure is, he or she needs to ensure that he has Docker tool installed on his machine, and then he can simply use Docker run commands to pull the image from the repository and run these as containers. And these containers are going to run the same way everywhere. Why? This is because, I mean, whatever we are trying to run, it's already part of the Docker image. So this image is going to run the same way everywhere wherever you have Docker tool installed. Okay, so in this way, the behavior of the application also is not going to change. So this is the beauty of Docker, and this is the main concept of Docker, and this is why we all want to use Docker containers to deploy our applications. Okay, I hope the concept is clear. If you have any questions, please reach out to me in the comment section. Alright, so next we will see how to install and configure Docker on a virtual machine. Okay, so I will be using an AWS EC2 instance with Ubuntu 24.04 LTS AMI to install Docker. You can use any other operating system of your choice. You can go to docs.docker.com, which is the official documentation of Docker, and there you can find the installation instructions for all the operating systems. Okay, so I have already opened this in my browser, and let's see what all steps are given there to install Docker. Okay, so it's pretty simple to install Docker. There are only 3-4 commands that you have to run. Okay, the first command is, you just have to scroll down and find the commands. So this is the command which is going to check if any existing Docker packages are installed on your machine or not. So you can just copy and go to your this VM. So I've already logged into this AWS EC2 instance based out of Ubuntu 24.04 LTS. So I'll just run this command, hit enter, and it's going to check if any Docker packages are already installed. If yes, it's going to remove that, just to keep this installation absolutely clean. Next is, you have to set up the apt repository for Docker. Okay, for that you just have to copy this entire thing from here, go here, paste, and enter. So it's going to add the repository for Docker from where you can download the package. Okay, after that, scroll down, and then you can install the latest version of Docker. But apart from Docker, you have to install some other dependency package as well. Okay, so you can just copy and paste this command now, go here. The last command ran successfully, so run this command, hit enter. It's going to ask for confirmation. So it's going to take 437 MBs to install this package. So just type Y, hit enter, and then it's going to install the Docker package and all the dependency packages that you need to run Docker on your machine. Alright, and after you have run it, to confirm that this Docker actually ran successfully, this Docker installation ran successfully, you can just copy and paste this command. It is going to create your first Docker container on your machine. Okay, it's going to run a hello world program. Okay, and it's going to confirm that this Docker has been installed successfully on your machine. So just copy and paste, hit enter. Okay, so you can see the message, hello from Docker. This message shows that your installation appears to be working correctly. So this confirms that we successfully installed a Docker on our machine, and we also ran our first Docker container. To check all the running containers, okay, on your machine, you can run the command called docker space ps. Okay, we are seeing this permission issue because this Ubuntu is not part of Docker group. So any user on a Linux machine which needs access to Docker commands, that user needs to be part of a Docker group. Okay, so when you install Docker, it also created one Docker group. So any user which is added to it will get all the Docker permissions. So there are two ways to resolve this issue. Either you can use this command with sudo. That is going to mean that you want to run this command as root user. Okay, it's going to work like this. Okay, so we don't have any running container as of now. And the other thing is, you can add this Ubuntu user to the Docker group. Okay, we already know how to do that. We can use usermod command. So we can do usermod space hyphen small a, capital G, name of the group, it's going to be Docker, which is the group, and then name of the user, which is Ubuntu. Hit enter. Okay, sorry, I have to be root to run this command, so I will supply sudo as the prefix. Hit enter. And then now if I run that same command, docker ps without root. Okay, I have applied the changes. I mean, I've done the changes, but the changes haven't been applied. So the best thing to do is log out and log back in. Okay, now if I run the command docker ps, you can see I'm not getting any permissions error. Okay, but I don't have any running container as of now. To list all the containers running or stopped or exited, you can do docker ps space hyphen a. This a means all. So now you can see I have one stopped container, which was the hello world container, okay, which we just ran. So because that container was only to confirm that this Docker installation was successful or not. Okay, so it just ran, it confirmed, and it stopped. Okay, now on my PPT, I have few more commands that I want to talk about. Okay, so the first command I want to talk about is sudo systemctl status docker. So when you install Docker, it's going to install a daemon, okay, on your machine. It's called docker d. Okay, so it continues to run in the background, and you can check the status of it if it is working or not using this command. So as you can see, this Docker is working fine. Okay, the status is active, running, and it is enabled as well. Okay, it's been running since 4 minutes and 1 second. So it means that this Docker service is running fine. Okay, next I want to talk about, so I wanted to show you this because if any issues with this service, so just check the status of this Docker service first, if it is running or not. Okay, and then you can look at its logs also to check if it is, I mean, failing with some error, or if there's any issue, it will be shown in the logs. Okay, next is, okay, these two commands I just covered, that this docker ps means to check the status of all the running containers. Then if you want to check all the containers, whether running, stopped, exited, then you can just supply -a. So it is docker ps space -a to check all the containers on your machine. Okay, then I also explained this command where I wanted to add this Ubuntu user to Docker group, so that Ubuntu has all the Docker permissions to run all the Docker commands. Okay, so this also we have done. Now after this, we will see how we can actually create a first meaningful Docker container application, and how to see if it is running or not. Okay, so what I'm going to do is I'm going to create a Jenkins application. So I'm going to deploy one Jenkins application as a Docker container, and then we will see how that application looks like. Okay, so for that I've already have this command here. Okay, it is okay. Just before this command, I want to explain another concept to you. Okay, so I'll just explain that concept and then I'll come back to this Jenkins Docker container. I'll clear the screen. So the first command that we ran to create our hello world container, I want to explain a few concepts around that. So this was the command that we ran. Okay, now how this command works and what is the structure of it. So just understand, this docker run command is used to create a container always. Okay, so docker run command is used to create containers. Now when I run this docker run hello world, this hello world is the name of the Docker image which is going to be used to create this container. Okay, if you remember from our past slide where I spoke about how Docker works, so the first thing is you have to create your this Docker image. Okay, then this image is deployed as a Docker container. Okay, so when I'm running this command docker run, I want to create a container but using an image, and the name of the image is hello-world. Now the next question is where this image is, because I did not create any hello world image. Okay, so from where this docker run command is getting this image and it is able to create the container. So it is able to get this image from a Docker registry. Okay, so a Docker registry is the place where all the Docker images are kept. Okay, but we did not configure any Docker registry also. So what happens when you install Docker? Initially you get one default public repository that you can use to have access to some commonly used Docker images, and that is given by Docker to us. That is called Docker Hub, and its address is hub.docker.com. So let me show you that. So this is the address of the public repository that is configured by default on any machine where you install Docker, and it is given by Docker to us. Okay, Docker company to us. So here in this search box you can search for all the images that are available on this registry. Okay, so here as you can see, I just search for this hello world and I was able to see this. So this is the image that our machine just pulled and ran it as a container, and you can see it has been downloaded 1 billion plus times. Okay, and then you can get all the information around the different tags, which I'll be talking about in much more detail as this course moves ahead. Okay, just understand that all these images are coming from here. Now also I would recommend that you create a free account on this website, and then you can have access to some more things, like if you want to push your customized images to this repository. So if you have an account on this, then you can do so. Okay, and it is pretty simple to create an account here. You just have to click on this sign up button, and then it's going to ask for a few details, like you do on any other website. Okay, and you can create your account. All right, so this is what I wanted to share as another important concept. Okay, yeah, so after this, let's go back to our PPT and see how we can deploy a Jenkins Docker container and then access the application as well. Okay, so this is going to be interesting because this is going to be one of the meaningful applications that we are deploying. So as I mentioned, all this information related to this image, because I did not get any image, all these images are available on Docker Hub, the hub.docker.com. So you can go there and you can search for these images. All right, so I already have this particular command here that I can just copy and paste and run to create my first a Jenkins Docker container. So I'll go here, I'll clear the screen and I'll run this command, and I'm going to explain this to you a little bit before I run this command, because I'm using some additional flags here. So apart from Docker run, I'm using some other things as well. So here I'm using Docker run, then I'm using -d. -d means detached mode, which means that I'm trying to run this command in the background, because if I don't supply this -d, okay, so I mean when this container runs, it's going to be attached to the to the terminal, which means that I will not be able to run any other commands. Okay, so it is like the best practice whenever you are using this docker run command, always specify -d so that you can get your terminal back. This particular container is going to run in the background. Okay, so I'm using this -p option with, and I'm specifying this 8080 then colon 8080. So why I'm doing this, since I'm using Jenkins, so Jenkins default port is 8080. So inside the container, this application is going to run at port 8080. I'm going to give you a lot of details around this concept, but just understand on a very high level that whenever you are running any container, okay, and if you want to access that container, so you have to specify the ports. I mean, you have to specify the port mapping flag as well in your Docker run command, so that you can access that particular application running inside the container from your machine. Okay, because by default it is not accessible. Okay, so what I'm doing is, when I'm using this -p 8080 colon 8080, which means this first port is the port on my machine where I'm running this command, and this next section is inside the container. So I'm trying to forward the traffic from this machine, Ubuntu machine, on port 8080 to the port inside the container where this Jenkins container is running, which is port 8080. So I mean here you can use other port number also, but I'm just keeping it really simple. So I'm using the same port, but you can use 8080 or 8081, 8082. It's up to you. Okay, but I just wanted to keep it simple. So I'm using 8080 here, which is the same port on which this Jenkins container is going to run inside the container. The Jenkins application is going to run inside the container. Okay, then I'm using restart option also. So Docker has some additional parameters like restart. I'm saying on failure, which means that if this Docker container fails, then it's going to restart itself to fix the issue. Okay, and then I'm specifying the name of the Docker image with a particular tag. So anything after colon is the tag, because we can have multiple versions of the same Docker image. So we can specify a particular tag to point our installation to a particular tag of the Docker image. So okay, so here I'm using LTS-JDK17. That's it. Also, I can add another parameter. Let's do that. I can also name my container, else I will get one automatic name by Docker. So we can use --name, and we can name our container as Jenkins only, and then hit enter. So now it's going to do, what it's going to do, it's going to check first if this particular Docker image is available on your local machine or not. Okay, if it's not, then it's going to pull that image from Docker Hub, and then it's going to run the container out of it. But actually it is the container ID. So this is the ID of your container that you just ran. Okay, this long ID. And to check all the running containers, as I just mentioned, you can use docker space ps command. It's going to see it's going to show you all the running containers. As you can see, we were able to run this container called Jenkins. Name of the container is Jenkins, and it is running since 32 seconds. And ports, you can see it has been mapped to 8080. Okay, on the host machine. So all the traffic on this Ubuntu machine's 8080 port is going to be redirected to 8080 port inside the container. Okay, so that we can access that application on our host machine. Okay, so to access the application, what we can do, we can copy the public IP address of my Ubuntu machine and then supply this 8080 port to access the application. So to do that, I'm going to go to my AWS Management Console and I'm going to copy the public IP address, which is this one. And I will open it in a new tab, paste, and then just add the port 8080 and hit enter. So as you can see now, I'm able to access my Jenkins application, which is running inside a container on my host machine. You just have to ensure, since I'm using this port 8080 to expose the traffic, you have to ensure that in your security group in AWS, you're allowing this traffic on the inbound of the security group of your EC2 instance, like this. So this is the security group that I am using, and on the security group on the inbound, I have to allow this 8080 port as custom TCP. Okay, so you have to allow this. Okay, I mean, you can use this 0.0.0/0 to keep it simple, to allow this port from everywhere. Okay, and then it's going to work, else it is going to fail. Remember this. All right, so I'm able to access my Jenkins application. Now to get started with Jenkins, this is not a Jenkins session, but anyways, we have to use some of the Jenkins concepts so that we can access our main application page or the main dashboard. Okay, so here you can see, to ensure Jenkins is securely set up by the administrators, a password has been written to the log, and you can find the password at this location. Okay, so what you have to do is to access this particular password, which is inside the container, inside this location. Okay, I already have the command. You just have to run this command to get the password, which you can enter on the screen here to have access to your main Jenkins dashboard. Okay, I'm going to explain this command to you. So what it's doing is, this docker exec command means if you have a running container running and if you want to log into that running container, okay, you can use this docker exec command. Okay, so what I'm doing is I'm logging into the running container. Here I will provide the container ID, which I got after I ran the docker container, and then inside the container I'm going to run this command in one go. I don't have to log in and then run this command manually. I can run the command from outside also. So I'm just specifying that I want to run this command inside the container with this container ID. Okay, so this is the container where I want to run this command to get the password of Jenkins UI. Okay, so what I have to do is, first I have to get the docker ID. For that I can run docker ps. I can copy the ID from here, and then I can okay, what I'll do is I'll just replace this container ID with the container ID that I got, like this, and then I'll copy this entire command, copy and paste it here, hit enter, and you can see I got this random alpha numeric values, and this is the password to access my Jenkins UI. Just paste it here, hit enter. It's going to ask to install some plugins, which I don't want. Okay, I'll just use the suggested plugins only, and I'll just click on it. Some issue, but I'll just try again. Okay, this time it worked. So it's going to install some default plugins, and it's going to take me to the home page of Jenkins. All right, so this is done. Now it's asking me to create some admin user. Okay, I don't want to do that because this is not a Jenkins class. I just want to skip and continue as admin. And this is going to my this is going to be my Jenkins URL to access. That's fine, and click on save and finish. start using Jenkins. And then I will see my default Jenkins dashboard here. Okay, so this is like a full-fledged application that you can use to create your Jenkins jobs. Okay, so you can use it as a full-time installation of Jenkins. So this is how it works inside the Jenkins. Okay, so you can click on this new item and try to create one job, maybe a test job. And we can create a freestyle project. Enter. Now just click on OK. And you can just use different options. If you want, you can attach Git repo here if you want to. I don't want to do that. I just want to execute a shell. I'll just type here echo dollar host name, save, and I'm going to click on build now. And let's see if we can have a successful job ran. Okay, it ran. You can check the console output. Okay, so it's going to show you what you did. So I just ran this command called docker echo hostname, and you can see it just gave the hostname, which is this one. So this is the hostname of the Docker container and not my Ubuntu machine. Okay, because this is running inside Docker container, and this is the hostname of the Docker container. And as you can see, it is the same which we used. So this is the same container ID. Okay, if I go here again, you can match it. It's ending with ADF85, ADF85. Okay, so it is giving us the right hostname, which is also the container ID of the Docker container that we are running. So this is how you can create, you can deploy an application as a Docker container, okay, on a machine where you have installed Docker. Okay, so it is running inside the container on my Ubuntu machine, and I can run these multiple containers now. As I showed you in the PPT also, you can run multiple containers in their own isolated environments, okay, using this docker run command. So I can run this command multiple times, okay, and I can get multiple containers. The only condition is you should have the resources available. You should have the RAM, the memory, and storage available on your main machine to create these containers. Okay, that is the only requirement to run multiple containers on the same Docker host. Okay, Docker host is where you install Docker tool. It is called Docker host. I hope this was clear to you. Alright, so now let's take a look at most common Docker commands used. The first command is docker run, which is to create and start a new container from an image. We just saw how we can use docker run to create a new container. We just created the Jenkins container. Okay, so that's where we use, and it is one of the most important commands in Docker for sure. Next command is start, restart, or stop one or more stopped containers. So your Docker container can have various statuses. Okay, it can be in started status, which means that the Docker is currently running. It can be stopped. It can be in exited status. So you can so you have some commands where you can start a stopped container, or you can stop a start container, or you can restart a container. Okay, so let's see this in action. So let's see what all containers I have running on my machine. So I have one Jenkins container. It is in running status because I ran this command docker ps, which means this a particular container is in running status. And you can see this has been up 23 hours. So I'm recording this video after some time after I created this Jenkins container. Okay, so that's why you see this. It was created 23 hours ago. Okay, all right. So what we can do with these commands that we just saw we can stop a started container. So this is a started container. This is in running status. So we can do docker stop, then either the container name, which is Jenkins, or the container ID. So you can reference any container in these docker commands by either using the container ID, which is this long ID that you see here, or you can reference these using the container name. In this case, it is Jenkins. So let's use this ID. So this is going to stop this container. And now if I run docker ps, I won't see this in the running container list, but I will be able to see it in all containers on my machine list. So as you can see, the status is now exited, which means it has been stopped, and it was just done 11 seconds ago. Okay. Then if we want to start this container, we can just repeat the command and just replace this stop with start. It's going to start the container again like this. If I check again, I will see this container is in running status up 3 seconds. Okay, if you see here, this was created 23 hours ago, but it went into stop status, and I again started it using the docker start command, and now it is up. Okay, 3 seconds ago. Then you also have command called restart. So you can restart a container. Just like you restart a virtual machine, you can restart a container as well. If I check the status again, you will see this time is again up 3 seconds. Okay, because I just restarted the container. All right. Next is docker rm. So docker rm is used to remove any container which is running on your machine. Okay, how you can do that? Again, you can use docker space rm. Rm is referring to remove. Then either the name or the container ID. Okay, but you will always see this message, error response from daemon, cannot remove container. Container is a running status. Okay, so it is like a type of a surety that Docker gives you, that you cannot just remove a running container straight away. Okay, either you have to stop it. So it clearly says that you need to stop the container first before you can remove it, or you can force remove it. You have the option to do it forcefully. For that, you just have to add a flag -f like this. So what you're trying to do is you're trying to forcefully remove a running container like this. If you see this container ID, which means the command ran successfully. So now if you do docker ps, you won't see it. Even if you list out all the containers, it won't be there because we have completely removed this container. We did not stop it, but we removed it. Okay, so you won't see that container here. Okay. Next is docker exec. So docker exec we also see when we ran our Jenkins container, where we wanted to retrieve the initial password that we need to log into our Jenkins UI. Okay, so we use that docker exec command, but let's do it again. So what I'm going to do is, so we just removed that container already. So we will see what all images we have. And we can see we still have this Jenkins image on our machine, on my local machine. So I'm going to run the docker run command again. So what I can do is I can do run history, and I can grab for that. So I'm going to grab that command. And this is the command that I want to use. Okay, so I can just repeat this command by using exclamation, then the command number, which is 21. It's going to create another container for me. I got the container ID. If I do docker ps now, I will see another container running. Okay, so this is a new container. So just remember this thing, that a single image can be used to create multiple containers on the same machine. Okay, so I mean keep on running this command, docker run, and I can get these multiple instances of the container from the same image. The only condition is your underlying virtual machine, your main machine, should have the resources available to support these new containers. Okay, if the resources aren't there, then you won't be able to create it. Okay, it's quite obvious. All right. So so we wanted to try the other command, which is docker exec. Okay, so let's see how we can run that. So we can run any command inside the container using docker exec command. Okay, so let's try to run a command inside the container that we have. So docker exec, then you can use either the container ID or the container name like this, and then you can run any command. For example, when I'm logging into this container, I will be reaching the default working directory of the container. So I want to list out the contents of that directory. So you can do ls, hit enter. So I can retrieve some information from inside of the container using docker exec command. This is fine. But what if I want to supply some commands from the terminal inside the container? So just like you log into a virtual machine, you can log into a running container and you can supply the commands as you do in a virtual machine. So how to do that? Let me clear the screen. So docker exec, and then after that I'm going to supply two flags to it, to this command, -i and t. Now what is the meaning of this? I want to interact with the container because I want to supply some commands, okay, from my end to the container. Okay, for that I need to interact with the container. So for interacting with the terminal, to interact with the container, you have to supply these two flags, -i, which stands for interactive, and t stands for terminal. So interactive terminal. Okay, so I'm attaching an interactive terminal to the container. To which container? To this container. But you cannot run this. I mean, you cannot run any commands just like this on a container. You need a shell where you execute the commands always, right? So to execute the commands, you have to specify a shell also, which is present inside the container. Okay, so generally, if you see, most of the containers that you will be running, they will at least have sh shell, generally speaking. Okay, so it depends from this one container to the other which container you are using, but I mean mostly you will see this sh shell is available inside of most of the containers. Okay, so I'll just repeat myself. What I'm trying to do here is I want to run some commands inside of the container just like I do on a virtual machine. To interact with the running container, you have to specify -it flags along with the exec command. IT stands for interactive terminal, but interactive terminal can only be used along with the shell because the shell is going to execute the command. The interactive terminal is going to be used to input the commands to the shell. Okay, so this is how it works in Docker. So just after I do that, now I'm logged in inside the container. I'm not on my virtual machine. Okay, so from here I just logged into the running container here. How to verify that? If I do echo $hostname, you can see the container ID. That's the same container ID that I used to exec into the container. Okay, so if you see, this is the hostname, which means I'm inside the container and not on a virtual machine. Okay, if I do Control D right now, then I will again log out of the container and I will reach back my main virtual machine. Okay, so let's run the command again to get inside of the container. Okay, so I'm inside the container. I can do ls. I can list out the contents. Okay, also what I can do is, if I do curl localhost 8080, I can see the output. Okay, I did not get any error, and you can see it says authentication required because what I try to access the Jenkins Jenkins UI from the CLI. okay, which is available on port 8080 inside the container on localhost, which means I'm trying to access the IP address of the container with 8080 port number. So I got this message, which is the default Jenkins UI page, okay, which means that our Jenkins is currently running. Okay. So this is how you can interact with the running container, and you can do multiple things here. Okay, depends on the use case, but I just wanted to give you an idea what is the meaning of this Docker exec conceptually. All right, let's come out of it. Next command, Docker logs command. So once again, there are scenarios wherein you will need to troubleshoot and identify some issues with your container. So you can use the Docker logs command to check the logs of the container. So what I'll do is, let me clear the screen. I'll do Docker logs, then the container ID. Sorry, I need to copy the container ID again. So I'll do Docker space PS, and then I'll do Docker logs and then container ID. So I can see all the logs that are currently there in my Jenkins container. Okay, so this is the way you can check all the logs. Next is Docker PS -a, which we already saw. Okay, so no need to repeat that. So it is this Docker PS is used to check the running containers, and Docker PS space -a is used to see all the containers whether running or stopped. Okay, all the containers will be visible when you run this command. Then another very important command is build an image from a Docker file. So I'm going to talk about Docker file in much more detail in my next video. Okay, in this video, I just want to give you a high level overview of how we can build a custom Docker image. Till now, whatever images we have used from Docker's public repository, which is Docker Hub. Okay, which is also called hub.docker.com. I mean, hub.docker.com is its address, website address, but it's called Docker Hub. Okay, but when you're working in a real-time environment, when you're actually working on your DevOps projects, you will be writing your own Docker images. Okay, which means that you will write the logic to create the Docker image. You will create the Docker image, okay, on your own, and then you will be getting the containers out of those images. Okay, that's what happened. So we use this command called Docker build command to create our own image, own Docker image. All right, but there are some concepts around how we can build a Docker image. Okay, so as I mentioned, I'm going to cover this Docker file concept in much more detail in my next video, but in this video I will give you some information on it. Let me clear the screen. So if I do ls on my machine, I have two files. I have this Docker file and I have this index.html. Okay, so to create your own custom image, okay, or I should say to create an image, you need a Docker file always. So a Docker file is the basis of any Docker image. Okay, so then there are some ways by which you can create a Docker file. Okay, and let me just show it to you what all is there in my Docker file. So a Docker file always starts with a base image, which means that you need an image which is already there that you can use to start getting your own Docker image. Okay, so a Docker file always starts with from statement. So from is only specifying which Docker image should I use as my base image. So it is Ubuntu in my case. Then what you do, you use this image and then add some additional layers on this image to create your own image. Once again, it depends what kind of application you are trying to deploy or you are trying to create. So it depends on that. So you will have these different layers. So these are the layers of a Docker image. Okay, so you start with this base image, then depending on your use case, you are going to use these different instructions. These are called instructions in a Docker file that you use to create your own custom image. Okay, so you will add all the steps that you need to create your custom image for your application like this. Okay, once you have this Docker file ready with you, then you're going to run this docker build command. So how to use this docker build command, let's see that as well. So we'll do docker build, then try to tag our image because we need to give it a name as well. So for that we can use -t command with this docker build command. So this -t is specifying what are the tags that you want to attach to this new image that you're going to build. So what I can do is I can name this image as use Apache 2 tech. Okay, just to keep it short. So this is how you build your Docker image. Docker build -t. Okay, and I'm just specifying this tag here, which is it is going to be the name of this new image that I will be creating using this docker build command. Then after this, you have to specify the path of your Docker file. Okay, because this image is going to be built from this Docker file instructions. So this command is going to see what all instructions are there in the Docker file, and then it's going to build the Docker image from these instructions. So here you have to specify the path of the Docker file. But since I'm running this command inside the same directory where I have this Docker file, then I can specify the location of my Docker file is dot, which means the present working directory where I am right now, where I'm running the command. So I'm just specifying that same path. Okay, and just after this you can hit enter. It's going to start building your Docker image. So as you can see, so these are the different layers, okay, that were built on my this base image which was there. It was Ubuntu in my case. So I used Ubuntu as the base image, and then on top of it I build all these different layers to create my custom Docker image. Okay, this is done. Now if I do Docker images, I will see my custom image as well. So I have this Jenkins image already, and this is my new image. As you can see, Apache 2 tech, and the tag is latest. So here when I use this tag, I did not specify any additional tags. So these tags these tags are used to create different versions of a Docker image. When you don't specify any tag, then it is going to be latest by default. Okay, it's going to take latest by default. So if you see this tag here, it's saying latest, which means it is the latest image. You can say that. Okay, so this is how this image is built. Okay, so this is how we use this docker build command. But as I mentioned, I'm going to give you a lot of information around this Docker file in my next video. But in this video, just wanted to tell you this docker build command. All right, we have our image now. Next is docker pull command. Now this docker pull command is used to download an image from registry to your local machine. So it is only going to download the image. It is not going to run a container out of it. So this is the difference between docker pull and docker run. When you use this docker run command, if I do, for example, let me clear the screen. If I do docker run Ubuntu, what it's going to do, it's going to check if this Ubuntu image is present on my local machine or not. If not, then it is going to try to pull or download from my Docker registry, which is Docker Hub in my case, and then it is going to run a container after downloading the image. So it's going to download the image from Docker registry, and then it is going to create a container out of it as well. Okay, so it's going to create the container as well after pulling it. But if I do just docker pull, then it is only going to pull the image. That's it, and it is not going to create the container. So this is the difference. Okay, so this docker pull Ubuntu, so Ubuntu already exists because I was using it in my Docker file in the previous command. So this layer already exists, so it is not going to download that. So this is also a beauty of Docker. You don't have to re-download the images. If the image is already there on a local machine, it is going to accept it from there, and it can use it to create any containers. Okay, even though it was part of my Docker file, but I can still use this base image for some other work also. Okay, I mean, if I want to use it in some other container, I can do that. Okay, so this Docker uses this cache on your machine to reference to any image that you are trying to work with. Okay, so this is the difference between Docker pull and Docker run command. The next is Docker push command. Now, after you have created your custom image, okay, if you want to push this image to a registry of your choice, okay, it can be a private registry. When you're working in real time, you will have a private registry. But in our case, since it is only a demo setup, we have a public repository, which is the default registry given by Docker to us. Okay, so if you want to, I mean, push any of your images that you've built, so you can do so using Docker push command. How to do that? Let's first see what all images are there one more time. So I have this image which I just built. If I want to push this image to Docker registry here, so this is my Docker registry, and these are my different images. As you can see, some of them are really old, like 5 years ago I built them. Okay, so this is the list of all the Docker images that are there in my Docker Hub account. Okay, so you have to create an account here. Okay, if you want to I mean, push your this Docker images, so just create an account and have your credentials handy so that you can log in to this Docker Hub from the CLI also. So before we can push our images to our Docker Hub account, we need to tag them in a particular format that is mentioned by Docker on their official documentation. So let me just go to the Docker's official documentation and show you what is mentioned there for Docker tag. So here I am on the official Docker's documentation, docs.docker.com, and here I am in the tagging images section, and this is the structure that I was talking about. So generally, if you are using a private registry, you would have a host name and a port number on which that private registry is configured. So while tagging the image, you can use that host and port number. Along with that, you have to specify /, then you have to specify the path and the tag of the image. So host, as I mentioned, it is optional. Registry host name where the image is located. If no host is specified, which is our case because we are using Docker's public registry, then the default one, which is docker.io, is going to be used. Then port number, again, if you're using your own registry, you can specify the port number on which your registry is configured along with the host name. Okay, but this is also not applicable in our case. Then path is the path of the image consisting of / separated components. Okay, so how this path is created for Docker Hub, the format follows namespace / repository, where namespace is either a user's or organization's name. If no namespace is specified, library is used, which is the namespace for official Docker images. So if you want to tag an image and I mean, you want to push it to your account, to your Docker Hub account, then this namespace can be your username. Okay, or if you are using an organization's Docker Hub account, then it's going to be an organization's name. Then / the repository. So inside your Docker Hub, you can create multiple repositories and you can group your images. Okay, so if I go to my Docker Hub account, you can see I have the option to create a repository. So let's just do that. So I'm going to create a registry, create a repository, and you can see the namespace is Bhavukam, which is also my username. Okay, so inside this namespace, I can create a repository name. Let's create repository as techapricate. Okay, I can copy this as short description as well, and it's going to be a public registry, and then I'm going to click create. So it's going to create another repository for me on my Docker Hub account called techapricate. Okay, so now on the right hand side you can see if I have to push any image to this Docker repository on my Docker Hub, you can use this command. Okay, docker push, then the name of the namespace / the name of the repository, and then the tag. Okay, so this is the tag that I'm going to use to tag my images as well. So I can just copy it from here, go here, paste it. Then I can use docker tag space, then name of the image, which is this one. So either you can use the repository name here like this, and the tag, which is latest. It's going to tag the image, or you can also tag the image using the image ID, which is the easier option. So you can do docker tag name of the image ID, and then this particular tag name, which I copied from my Docker Hub like this. Sorry, I didn't put any tag here, so let's just put it as V1 version. Done. Now if I check the Docker images, I can see, so since I tagged this image twice, okay, so it just took that default tag name, which is tag name, and in the second command I used the image ID to tag it with V1. Okay, this is fine. So the image has been tagged. Now I can push the Docker image. Okay, to push, again I can go to this Docker Hub account and I can just copy this entire thing from here if I want to. Okay, if I don't want to type, I can copy it from here, and you have to you just have to ensure that you're using the same tag as you use in the docker tag command, which is v1 in my case, like this. So you will get this message that the image has been pushed successfully. Okay, and if I go here, if I refresh, I can see the tag, the new image is available in my Docker Hub repository, right? Pushed less than a minute, and this is the image that I just pushed with the tag v1. Okay. Then one more thing I didn't show you. Actually, it didn't come up because I already did that few hours ago, so it didn't show up. So how I'm able to authenticate from my machine to my this Docker registry. Okay, so for that you have to run another command. So since I already used this command to authenticate, so it didn't come up. So you have to use this docker login command also. Okay, so I'm getting this login succeeded because I already logged in. So let me log out and then log back in to show it to you. Log out. So I'm logged out of my Docker Hub account on the CLI. Now I will do docker login command. So this is required before you can push your image. You have to authenticate to your Docker Hub account as well, right? So to authenticate, you use docker login command. Let's use this command actually, docker login -u, then username. So let me just come out of it. Docker login -u, then username. My username is Bhavuk M. It's going to be different in your case. Then it's going to ask for the password. So same password which you use to log into the UI Docker Hub account, you can use the same here. And you're going to get the message login succeeded. Okay, so after this step, you will be able to push the image as I just did in the last step. Okay, so this is how this you can create your own image, you can tag your image, and you can push your image to Docker Hub. I can share this image with you also. Okay, since if you remember, I created a public repository on my Docker Hub account, which means all these images are public in nature. So anyone who has access to this, who knows the name of this image, will be able to search for it on Docker Hub. So you can also use this image now to create a container on your local machine. You just have to install Docker, and you just have to run this command docker run, then this entire name like this, and you will be able to download the image and create the container on your machine using my this Docker image. Okay, and this image is going to work the same way as it is working on my image, because everything is inside the image only. Whatever it needs, it's already there inside the image, so it is not going to use anything on your machine. Okay, this Docker tool is going to ensure that this image is run as a container in an isolated environment on your machine, and whatever it needs, it's already there in the Docker image. So that's why the behavior of this container is not going to change no matter where you run this image as a container, okay, around the world, anywhere. I hope the concept is clear to you now, how this is working from Docker, pulling, then a Docker build, then Docker tag, and then Docker push. All right. Next is Docker images. So Docker images, we already saw, it's a command to list out all the images. Either you can use Docker images, or you can also use Docker image ls command. It's going to give you the same result. It's up to you. Next is Docker Docker RMI, which is used to remove any image. So let's do Docker RMI, and let's remove an image. Let me remove this Ubuntu image. Okay, so you can use this name and tag, or you can use the image ID also like this. Docker RMI, and it's going to remove the image. It's going to delete the image. Okay, so RMI means remove image. Then Docker tag, we already saw how to tag an image. Then Docker stats, to display a live stream of container resource usage statistics. So whatever is the resource utilization of your Docker containers, you can see it in Docker stats command. So let's go here, let's clear the screen, and let's do Docker stats. And you can see there's only one container which is running, and it is consuming 0.12% of my virtual machine. And this is the memory usage and the limit that is set, and this is the memory percent. So you can see all the system, or you can see the container performance metrics here, okay, of your container using this Docker stats command. Next is Docker system df, which is going to show you how much storage is being currently occupied by Docker resources on your virtual machine. So you can run this command, Docker system df, and it's going to show what all resources are there and how much storage is each type of resource consuming on your virtual machine. Okay. Next is Docker history command, which is going to show you the history of an image. So this Docker history command is used to check the different layers of the image. Okay. So I'm going to talk about this Docker image layers in my next video in much more detail. But just remember, this Docker history command is used to check the different layers of the Docker image. So you can use Docker history, then the name of the image. For example, if I do Docker history, and let's use the name of my image, which I just pushed, and you can see all the different stages, or the different structure, the different instructions which was there in my Docker file. So all those were different layers of the image that you can see with Docker history, which means how this image was actually built, what steps were being used to build this image. So you can see all that in Docker history command. Next is Docker inspect. So Docker inspect is used to inspect a Docker element or Docker object like this image only. If I do Docker inspect, let's copy this again, hit enter, and you can see all the different details of this Docker image. So here it was showing only layers. Now it is giving us some additional information related to the Docker image. Okay, similarly you can do with a Docker container also. If I do Docker PS, there's one running container. You can use Docker inspect. Like this. And for example, I want to check the IP address of my running container. Okay. So I can check that here. So this is the IP address of my container. This is its gateway and some other information as well related to the Docker container. Okay. So you can see all the information. It is running on port 8080. The host port is 8080. And it is running on port 8080 inside the container. Okay. And then you can see the gateway ID. If you see some additional details, name of the image, and whatever environment variables are there in the inside the container, you can see all that, and some additional information as well depending on what you want to see. So all the networking information related to storage mounts, related to some of the details related to your Docker container. So all that configuration is available in Docker inspect command. So it's going to return low level information on Docker objects. So next is Docker volume ls. Now by default, if you don't configure any volume inside your Docker container, so what happens, whatever data is there inside your container, when the container is killed, the data is lost along with it. Okay, this is because Docker containers are ephemeral by nature. You can say they don't have any default mechanism to store data inside them. Okay, so once they are terminated or they are killed, the data inside the containers get lost. Now to overcome this problem of data, because we will have applications deployed where we want to have a persistent data, right? So to have this data persisted, even if the container is killed or terminated, we use the concept of volumes. Okay, so once again in my next video I am going to give you some additional information related to the different type of volumes that we can configure inside a Docker container. For this video I just want to show you the commands that we can use related to volume. So you can use a Docker volume ls command to list out the volumes. Okay, this Docker volume ls is going to list out all the volumes on your virtual machine. Then if you want to create a new volume, you can do Docker volume create and then the name of the Docker volume create and then name of the volume. We can do like test vol. Then now if I list out the volumes, it's going to have an additional volume test vol which I just created. So this is the way you can create your own volume and use it with your container. Okay, which we will see of course. Then Docker volume inspect, again you can inspect a volume as well using Docker volume inspect command. So Docker volume inspect, then the name of the volume to check additional details, some low level information related to the volume. Okay, so you can see all that where the this volume has been mounted. It is mounted on this location. This is the name and some additional information as well. Okay, then similarly you can remove this volume using Docker volume rm command. So Docker volume rm, then the name of the volume which is test vol. So the volume is removed now. Okay, we won't see it now in Docker volume ls. So the volume is removed. So the last command in the list is Docker system prune. This is a very useful command if you want to free up a lot of storage space on your virtual machine that is occupied by Docker resources. So you can use this command. It's going to remove all the unused containers, networks and images related to Docker. So when you run this command, you're going to get a warning. Let's try this now. So it's going to warn you that you are trying to remove all stopped containers, all networks not used by at least one container, all dangling images, and unused build cache. If you are 100% sure, only then press yes. If not, then press no. So you have to be really careful using this command. Okay, it is very useful, but you should know that whatever you are trying to delete, you're not going to use it any further. All right. So those were the commands that I wanted to cover in this video. I hope you liked and you were able to understand all of these. If you have any doubts related to any of these commands, you can always reach out to me. Okay, and one more thing, I would highly recommend that please go through the official documentation of Docker that is on docs.docker.com, where you will find all the authentic information related to all the concepts. Okay, related to Docker. So I mean, if you really want to build on your fundamental knowledge of containers, so I always recommend going to the official documentation more instead of reading out from random articles. I know, I mean, some of the articles are really good, but try to find the information on the official documentation page first. If you don't find anything there, then you can always look for articles and blogs elsewhere. All right. So next is Docker image versus Docker container. So once again, a very important concept to understand, both from interview point of view and from actually working in the real environment. So sometimes the beginners tend to confuse between Docker image and Docker container. So let's start. So we've already seen a lot of practical, how to create a Docker image, how to run it as a container, and how to push the images to a Docker registry. Right. So some theoretical information on what we've already learned. So a Docker image is a read-only template with instructions for creating a container. Okay, we already saw that Docker image has several layers. Those layers are defined in a file called Docker file. So it's like the blueprint. Okay, so this image that you create from the Docker file, it's like a blueprint that you can use to create the container. Okay, so it's a read-only template with instructions for creating the container, and a running instance of a Docker image, like an actual object built from the blueprint, is your Docker container. So this is static in nature, and this is actually dynamic, and this is the real application. Okay, so this is just a file to create your container, and this is your actual container which hosts your website, your application. Okay, so it is dynamic. It can be started, stopped, modified, or deleted, but this is static and it does not change unless you rebuild it. So in terms of persistence, it is immutable, because once you have created the image, it cannot be changed. How it can change? Only when you use that image to create a new image. So you add some more layers to it. Okay, only in that case you can modify a Docker image. Okay, then Docker container, changes to the container are lost unless committed to a new image. So Docker containers are temporary in nature. I already told you these are the ephemeral resources. Okay, by default they do not persist any data inside them. So once they are killed or terminated, the data inside them is also lost. Okay, but there's a way by which you can create an image from a running container also. Okay, I'm going to show you that in my next video, probably. Okay, so just understand that by default the containers are always temporary. They're not designed by default to hold any data inside them. Once they are killed or terminated, the data is lost. Okay, so this is also another difference between a Docker image and Docker container. Then used to create Docker containers. So a Docker image is used to create the Docker containers, and Docker containers are used to run your applications based on the images. So these are your real application instances that you run as a container. Okay. Then storage, you can store the Docker images on various Docker registry platforms like Docker Hub, which is the default one, the public registry given by Docker to us, or you can use in AWS, we have a service called ECR or Elastic Container Registry. Okay, we're going to see a lot of ECR in our videos. I'm going to show you everything, how to set up an ECR repository, how to connect it with an EKS cluster, how to deploy applications. All that is going to come up soon. Okay. Yep. And in terms of Docker container, it runs in the Docker engine consuming system resources. It means that whatever host you install Docker on, it's going to consume the resources in terms of compute, storage, and networking, all the resources of a computing virtual machine. It's going to be used inside the container. Okay. Yeah. But in case of an image, it's only going to be storage that it's going to capture, because it is just a file that needs storage space. Okay, but a container is a computing resource. Okay, it needs computing resources to run your application inside the container. Then a lifespan, the image is going to be there till a lifetime until you manually delete your image from storage. The container only exists when it's running. Okay, so it can exit, it can pause as well. Okay, it can stop as well. So all those things are possible. So container is actually called a running instance only when it is in running status. Then isolation, as I mentioned, it cannot be executed. It is just a file. You cannot execute this file, but a container is the main application that provides an isolated environment for the application execution. Then creation is built using Docker files with instructions for the environment and dependencies. Okay, so as I mentioned, a Docker image is created from Docker file, and this Docker file has the instructions to build your Docker image. Okay, and once you have built your Docker image, then you use it to create a container. Create the image from the image using Docker run command. So the workflow is you create a Docker file. In Docker file, you enter all the instructions, all the different things that you need for your application to run in terms of its dependencies, its libraries, all the runtime environment that your application needs to run. It should be there in the Docker file instructions. Once you have your Docker file, you use that to create a Docker image for your application, and then you use this Docker image to create a running instance of your application as a container. Okay, so your application runs inside the container as a process. Examples. So this is how images are tagged or named. So nginx : then the name of the tag, because this one image can have various versions of it. So you have this versioning option also in your Docker images. So you can name your image and you can tag it with some version as well. Okay, and then in terms of container, it is running instance of nginx serving a website. Okay, I also want to show you a diagram just to give you a very rough comparison. So if I go here, so image is static, as I mentioned. Okay, and a container is actually the running instance of the application. The users access the application by accessing the container. Okay, and not by Docker image. Okay. Also, if I have to do a very rough comparison, Docker image can be thought of as an AWS AMI, Amazon Machine Image, which is used to create your EC2 instance. So your EC2 instance is equivalent to a container, and your AMI is equivalent to a Docker image, a container image. Because if you remember from our AWS series, AMI is used to create EC2 instances. So AMI here is like a template, is like the set of instructions, the set of softwares that you need in your EC2 instance. So you use this AMI as the basis, as the blueprint to create your EC2 instance. Similarly, you use a Docker image as the template, as the basis. It has all the different instructions, okay, which is required for your container to run. Okay, so just like AMI is able to create an EC2 instance, a Docker image is used to create a Docker container. Okay, so in this way you can do a very rough comparison. And as I mentioned, this container is also like a small virtual machine. Okay, so it is like a virtual machine, but it takes very less resources. It is really fast. It can spin up, spin down really quickly. Okay, and it will only run the process inside it which it needs to execute your application process. That's it. Okay, so this is the difference between Docker image and Docker container. I hope these differences are clear to you. Sometimes it can be asked in the interview as well. All right. So next is Docker's architecture. How Docker's architecture looks. Docker works on client server architecture. Okay, so when you are installing Docker on any machine, on any virtual machine, in my case, I installed it on an EC2 instance. You are installing multiple components of its architecture. You install one Docker client tool, also called Docker CLI. You also install a Docker daemon, which continues to run in the background. And this Docker CLI tool or this Docker client tool you use to interact with a Docker daemon. And this entire communication, it happens over a special type of communication channel called REST API. If I talk about REST API, REST stands for Representational State Transfer. API stands for Application Programming Interface. So we have different types of APIs. If I talk about API is a way, or you can say it is just a piece of code that is exposed by a particular application or a component as an endpoint so that other components or other applications can talk to it. In our case, it is the Docker daemon. So a Docker daemon has a REST API endpoint that is used by a Docker client to talk to it. Okay, so how it works? Here I'm talking about Docker run command. So here in this case, it's going to see if the particular image which you have included with your Docker run command is there on the virtual machine or not. If not, then it is going to talk to Docker registry, which is already configured in our Docker's configuration. It's going to talk to Docker registry and then pull the image from there. Okay, download it to your local machine, and then it is going to create the container out of it, and then it's going to send the confirmation back to your terminal that this particular Docker run command has completed successfully and a new container has been created. I'm just giving you a random example. This is how this entire architecture is working. So you're using CLI, you're using Docker daemon, and you're using Docker registry also. And this entire communication happens over this REST API, which I just explained you. So we have different types of APIs, but here in this case, it uses REST type of API. Okay, I have another diagram just to make it more clear to you. So whatever machine you use, whatever virtual machine you use to install Docker, it's called Docker host. So when you install Docker on this host, it becomes Docker engine, because it is the engine that Docker is going to use for all the processing. Okay, so when you install, as I mentioned, you install Docker CLI, you install Docker daemon, and the Docker client can talk to Docker daemon using REST API. Okay, and then whenever any instructions reach this Docker daemon, it's going to see whatever is the instruction. If it needs to download an image from registry, then it's going to do that. Okay, and then it's going to send the confirmation back as well to you on the terminal. Okay, so this is how architecture works. Okay, so we have three components mainly: Docker client, REST API, and Docker daemon. Okay, I hope the concept is clear to you. Once again, any doubts, please reach out to me in the comment section. So that's all I wanted to cover in Docker for DevOps part 1 series. Okay, if you liked it, please hit the like button. Please share this video with others who are looking to get a job in DevOps world, and please do subscribe to my channel. Alright guys, that's all for this video, and I'm going to see you in the next one.